We're going to discuss the concept of SQL injections. SQL injections are a very common type of vulnerability that exists inside of web servers and web applications. The idea is that if you have a SQL server that is typically queried, when the user queries that, if they have control over the input, they may be able to inject malicious code into that input in order to essentially be able to execute arbitrary SQL commands against your database. So to start off with, I have this login page that's vulnerable, but I want to give you a bit of an intuition behind the backend. So we have this localhost PHP myadmin set up. And inside of here, we have a users table. Inside of this user table, we have the usernames of each user as well as the passwords of each user. And again, typically when we store passwords, we would store passwords in a hashed format. However, in this case, I put them into plain text for the most part so that you can easily see what's going on and not have to sort of like work your way around like the hashing algorithms and that sort of thing. So very simply, when we query this database, if we want to check if a user exists, what we can do is we can do something like select username from users, where username equals test5, password equals 1, 2, 3, 4, 5, 6. When we query this, we're going to get back the username if the user exists. If it doesn't exist, we'll get back nothing. So that's a very simple example of how we could query this database to determine if a username and password matches something inside of the database. Now, inside of our PHP code for this login page, we do essentially that. So let me go ahead and show you. So inside of here, we have a PHP and HTML sort of setup. When we post the HTML form, it comes into our PHP code. Our PHP code gets the username and password inputted from the user. It concatenates them into that query that I was showing you before, and then it queries against the database. It then checks how many rows were returned, and if the number of rows is greater than or equal to 1, it means that it matched at least one user, so it sends you to the welcome.php page. Otherwise, it will tell you that your login was invalid. So if we were going to test this, we can input something like, test5, 1, 2, 3, 4, 5, 6. That would be a valid login. It takes us to the welcome.php page. If I enter something that's invalid, you'll see it says your login or password was invalid. So that's the general sort of flow structure of this login page. The problem with SQL injections comes from this concatenation here. When we concatenate the user input into the query itself, essentially what happens here is when we execute the code, it's going to see the user input as code rather than seeing it as input. So it's going to be relatively impossible for the SQL server to distinguish between the two, so it'll execute whatever's inputted as code. So to give you an example, when we come through here, if we were to input a password that had a double quote in it, so for instance, if our password was something like this, you'll see it ends up interpreting that as code and gives me a syntax error. What I can do is I can input something like this, or 1 equals 1, and then maybe a comment at the end. What this essentially does is it closes this off and it makes it where username equals test5 and password equals blank, or 1 equals 1, and then we comment out the rest to get rid of the syntax errors. 1 equals 1 is always going to be true. So since that is the case, when we execute this query, it returns back the whole table. So this is sort of the idea of what SQL injection is doing. We're essentially inputting in something that could be interpreted as code, and that code is going to allow us to either like return the whole table or potentially do other things. It really depends on sort of the application. For login pages, typically we want to make it return a valid input, so an actual valid login or something like that. Now, one thing you might note here is that we return the whole table. When we do this query here, we check if it's greater than or equal to 1 on the count. You may be asking yourself, well, what if we set it as equal to 1? And that's a valid question, right? If we set it as equal to 1, it seems like an okay defense for this. However, we can also inject limit 1 at the end, which will limit the outputs to just give us one result back. So it's not necessarily a good solution to just say, well, what if we just limit the input to 1 instead? We can easily write code to do that. So to show you this in action, if I type in like test, for instance, test5, we'll do the same user. As I said before, I want to input a single quote and then or 1 equals 1 and then a hashtag. So recall essentially what we're doing is we're closing this off to make it or password is blank. And then we're saying or 1 equals 1 and then we're putting that hashtag in. We'll forget about this limit portion here. Just keep it simple. We put in the hashtag, which comments out that last single quote that's left, which will make it so that the syntax is now valid. And now when we submit this, you'll see it authenticates us. So as you can see from this, I gave a totally invalid password. However, I still got access to the login page. So this is an authentication error. It allows us to authenticate to our web page without actually having valid credentials, which is a huge problem. Now, it's not the only place where this shows up, of course, and it's not always just explicit user input that allows for SQL injection. User input is just one of the attack vectors, but there's a lot of other places where it could potentially happen, and I'll talk about a few of those now. One other common place where SQL injection can happen is when we take server variables from the user. One good example of this is sometimes when a user visits your site, you can find their IP address using PHP. There's a possibility that the user could alter pieces of information that they're representing themselves as. I don't think IP address is one that you can really alter, but if you can look at things like host name or that sort of idea, the referrer, that sort of thing, if you put that sort of data into a database, for instance, you may accept it regardless of the format and concatenate it on. If the attacker is able to alter where they're coming from, for instance, like the referrer is a pretty good example. If they're able to alter the referrer to put in a malicious payload like this, they could potentially expose data from your database or cause it to do something bad, like insert a user, for instance, or drop tables, depending on the permission set of the querying agent, right? So this would be an example of another way that you could attack a server using that. Another common one is cookies. When you authenticate with a web page, you're typically given back a cookie, or if they're trying to track data from you, they'll give you a cookie. There's a lot of different instances where you get a cookie. And that stores a lot of different information inside of it. It's also controlled by the user. So the user could do things like modifying that cookie to be able to change the data of it. And again, they can change the data to something malicious like these SQL injection commands and manage to leak the database completely, right? So that's another example of an instance where we can do that. The final one that I'll talk about is ones that essentially happen on second order, is what it's referred to as second order SQL injection. And these are instances where suppose I put my username as something that's invalid, like this SQL syntax. It might not inject immediately, but maybe that username gets used somewhere else, and that place where it gets used is vulnerable to SQL injection from the programmers like trusting their own data over the data provided from the user. So you have to be very careful about how we accept data from users. If anything is under the control of user, things like file names, cookies, server variables, anything like that, we need to sanitize that data to make sure that the person isn't able to put malicious data inside of it. Any instance where you can put in malicious data is going to be an instance where you can have a SQL injection occurring. Now, to discuss a little bit about the types of attacks, we've discussed one type of attack here, which is this or 1 equals 1. It's typically referred to as a tautology. A tautology is a statement that always evaluates to true. These are really good for leaking data from databases that we shouldn't be able to see or forcing authentication and that sort of deal. There's one other type that's relatively common, which is referred to as a piggybacking query. With a piggyback query, what we do is we actually utilize unions. So, as an example here, when we set password equal to blank, we can also come over here and union it. So we could say union and then union another table. The only condition being that the number of fields has to match. So if you have something that returns back data from a database, for instance, and has 3 fields that it returns back, what you could do is you can union a different table. So for instance, in MySQL, there are a whole bunch of tables that store information like the tables that exist inside of a database, that sort of idea. So we can query that table with a union and be able to return that information. And then once we have that information, we can find more valuable tables like login tables, and then we can leak those types of tables as well. So this is known as piggybacking. You'll see this fairly often in a lot of different applications. One that is sort of like near and dear to me is content providers through Android. If you're not familiar with Android, essentially applications can export things called content providers. And what these are is they're special types of listeners that essentially allow people to query data from your application and it returns the data back to them. In these sort of situations, the user is able to control the projection, which is the fields that are inserted in, as well as the where clause. So they can do piggybacking queries fairly easily. And essentially what happens is you can piggyback on a union of all of the tables in the SQL database, and it will return it back to you because it doesn't really control what data is returned back. And that's one way that we can leak data through, say, content providers, for instance. And there are ways to protect yourself against those, of course, and we'll discuss some mitigation strategies that are relatively generic to any language. I'll show you examples of them, but that's just one example that I've typically seen that is typically not thought about, because a lot of the times people don't understand exactly what users are able to do when they query your databases. In these cases, we always want to make sure that we sanitize the user data. We always trust to set the user data as malicious. We don't trust user data. We always assume it's malicious and sanitize it properly, right? So let's discuss a bit about mitigations of these types of attacks. From now, you understand how an attacker can pull this off. So we'll discuss a few common mitigations and discuss sort of the pros and cons. One of the ones that I see very commonly is doing MySQL iEscape character. So you'll see here in the PHP code, I've added these MySQL iEscape character or escape strings. What these do is they escape SQL code. So if you put in like single quotes or that sort of things, it adds in escape characters so that they aren't interpreted as code, but rather as text. These are really great for situations where you have fields that require single quotes in order to close them. However, I want to demonstrate to you that this is not always a good solution. What I've got here is I've got an alternative version of our login form where we have the username and then we have the PIN as a password. Think of this like a bank PIN. If your bank accepts like a numeric input for the bank PIN, then you could have potentially a situation where you have an input for the password that doesn't have quotes in it, right? So you'll see here, if I go ahead and do like some SQL code, if I were to say where PIN equals 1234, you'll see when we execute this, we get back the PIN that's equal to 1234. We don't have to put the single quotes around it. It's not required to do that. So since this is the case, there's nothing that really can get escaped from this. So for me to demonstrate this, let's go ahead and go to this other page here. So we'll say login, what did I call it here? Login escape. And we'll go to give this a try. So again, if we do something like test 1234, that's a valid input. It lets us through to the welcome page. Now, if I do something like or 1 equals 1, you see how I put in like the closing quote there? This won't authenticate properly. You can ignore this error. That's just from me not properly sanitizing to make sure that the query is actually successful before I try to extract data from it. In a properly designed web application, you wouldn't have that error. But you can see next to that, the login is set as invalid, which is what we want to happen. However, I want you to realize if we don't put in the single quotes, we still get a valid SQL injection. We can say equals 1 or 1 equals 1, right? This input has no SQL characters in it. There's no special characters inside of this. It's literally just text. However, it's also a valid SQL injection. As you can see here, it authenticates us to the welcome.php page. So this is a word of warning. If the last thing in your where statement is numeric and it has no quotations associated with it, someone will be able to exploit it even if you escape the SQL characters. So really keep this in mind. A lot of people use that as a generic solution that always works. It does not always work. There are situations where that does not work, so you need to be aware of them and work with better types of mitigations. And the better types of mitigations are what are known as prepared statements. With prepared statements, what we do is we set up a statement to prepare a SQL query. When we prepared the SQL query, we put in question marks for the username and password. So we put question marks for the inputs, and then we bind the parameters to those inputs. So we say there's going to be 2 strings. Here's the first string, here's the second. What happens is when we go to query the database, it's going to take this username and it's going to place it in turn of this question mark. It's going to take this password, it's going to place it in turn of this question mark. And it's basically just going to replace the question marks with actual parameters. Why this works is because when we do a prepared statement with binded parameters, it ensures that it treats the inputs as inputs. It does not treat them as code. That's the key point here. We don't treat the inputs given from the user as code, so we're able to sanitize it using this type of prepared statement. This is the correct way to protect yourself from SQL injections. There's nothing wrong with also using like escape characters with prepared statements, but you should always use prepared statements if you're working with SQL queries. Just in general, anytime you're working with a SQL query, I would use a prepared statement. There's no reason to be concatenating user inputs to SQL queries, so don't ever do it. Just use prepared statements and you'll be totally fine. especially if you're getting data from the database. If you're getting data from anywhere, really just use these statements because you never know where an attacker might be able to get data into your database. They might be able to exploit it pretty badly with these sort of vulnerabilities. So this would be the main mitigation that we would want to work with. And in essentially every single different programming languages, there's a different way to prepare statements through the SQL libraries and such. So you just need to determine which one works for you. This is the PHP version. There's also another one in PHP called PDO. So there's really not much difference between PDO and using MySQLi. Again, it's really just up to preference of which one you like to use. When I was discussing the idea of content providers, there's one final thing that I want to discuss with this, and it's instances where you might be able to get input into the fields of the select statement. This is, again, not a particularly uncommon situation to happen. It happens with content providers I know quite frequently. I don't know about other types of SQL queries. There could be instances where you could select what kind of fields you want to put into a report, and that gets put into the select statement, right? What I want you to be aware of is, so if we say like username, for instance, the user can put in whatever fields they want. What they can do is they could do something like this. If they put in fields, they can say select is already there, and then the fields could be something like they could select username, password from users, right? Users is a different table. And then what they do is they just put a comment at the end of it. And what this does is it essentially creates a new select statement. So this is something you also have to be careful of. If you allow input into the fields, like in content providers in Android, you need to be aware that people can insert in any sort of SQL queries in there. They can put comments at the end of it, and they'll end up getting a perfectly valid SQL statement and manage to do an injection. The way that you get around this sort of thing is you check the user input to determine if the column that they are trying to access is actually a column inside of the database. If it's not a column in the database, we don't execute. We just say, hey, that column doesn't exist. If it is a column in the database, then we do execute and everyone is happy. So that's the main way to prevent against this. So all of this should give you a really good intuition behind how SQL injections work, generally, where they're typically located, what kind of attacks are typically common with them, and how to mitigate the attacks. So it's a good idea to go through your applications, make sure you're using the proper prepared statements, and try some of these exploits to see if they break your application. And if they do, make sure to patch up those problems because SQL injections are quite bad vulnerabilities. So this should help you out with getting that secured in any sort of web application that you have.